Okay, so here I'm pulling from a different kind of distribution called the Cauchy distribution. And here we'll look it up. We'll just look at 100 runs and see what we see. Okay, so, you know what? It looks like I didn't put in the min. We'll do that next time we run it. Okay, so what do you notice right away here with our distribution? Oh, actually it went a little, I'll just do another one. Okay, so tell me what you notice with this distribution, this 100 runs of a Cauchy distribution.
Well, things don't get smaller necessarily as you go further from the mean. Like, it seems like they kind of start to get smaller, and then they get bigger again over here, over there.
I mean, it also looks like there's a complete gap here. There are no data points where between like 5 and 7.
Yeah.
And then it starts up again.
And that's coming from the fact that we're only looking at 100 samples. But the problem is, most of the things you look at, you don't get a lot of samples.
Yeah.
And you're hoping you can infer what the distribution is. Do you think this could be a normal distribution? If I just showed you this picture, would you say, hey, maybe this is a normal distribution?
You could,
Yeah,
but
I guess.
maybe you have some outliers here, outliers there, and maybe this is all a bit more than you
What's the
would think it
max we're seeing here?
would. Max is 33.
Okay.
But
How
that's
about the min?
Negative 83.
That's not even displayed.
Yeah, that isn't displayed. So there's other data points that are way off over this way, and other data points that are way off over that way.
So maybe you couldn't even make the case that this could be a normal distribution.
Well, what did we see in our normal distribution?
Well,
And maybe it's scaled differently too. That could be a problem. But what did we see in our normal distribution?
I think it was like around 3 and -2 or something like that.
Yeah. Let's run it again and see what we see in this Cauchy distribution. Okay. What do we have now? Is this something that you think, hey, well, maybe it is a normal distribution? I don't know. It might be.
Well, not with the mins and maxes we're getting.
I mean, they did change a lot. I mean, I think it was negative. I think it was 85 for the max, and now it's 55.
Okay.
And I think it was around negative 55 for the minimum, and now it's negative 115.
Yeah, well, but still we only have 100 data points, and maybe the maxes would change a lot. Although, again, with our normal distribution, they weren't. What do you think is something we could do here to check?
Could run it with a bit more.
Okay, what would you like?
Maybe we could do like 10,000.
Okay, so what's your guess for the max now when we do it with 10,000?
Maybe
Or
around
the min?
150, or maybe negative 150.
150. How about you?
I think they'd stay in the same range. Like, I don't really have a good idea for what they can bounce around in. So I think they'll be around the same, maybe like 50 to 100.
Okay.
No.
What happened?
So there's just 2 columns, basically, that have virtually all of the data points.
Uh-huh.
And I guess that's because that's how it's being. There are a lot more data points that are out here and out there.
Okay.
So,
And the
yeah, we're
maximum
getting
minimum.
max and mins are massively different.
What happened to the max and mins?
They
They
got
went up
really
by orders of
wide range.
magnitude.
All right, so what if we ran 1,000,000? What do you think would happen? What's your guess for the maximum and minimum? Actually, I'll do 10 million.
Maybe like 130,000 and negative 50,000.
Okay, how about you?
I think maybe around maybe 200,000 and negative 200,000.
All right.
Ooh, well, they
Yes,
got a lot.
it's even bigger than that.
So what's happening? What is this distribution? What's it doing?
Well, it says that we've got the vast majority of the data is close to the mean, but you always have outliers, and outliers that are very, very far away.
Yeah, and these outliers. So it turned out to be, what is that, 4 million? I'm a little far away.
Yeah, 4.4 million.
And this is 11 million?
Yep.
Negative 11 million. So the Cauchy distribution has these rare events that are way out in the tails, but they could change everything. So Do you think this would be a good description for height? Do you think height follows a Cauchy distribution?
I don't think so, because you'll never see someone who is like 4 million feet tall.
Hopefully not.
Hopefully not.
Yeah, because we only did 10 million samples, right? So more people in the United States. There are more people in the United States than 10 million. And no one's 4 million feet tall.
Yep.
For sure. Okay, so let's look at something in the middle now.